Good. So welcome to the webinar. My name is Josh Long. This is my Twitter handle and my email. If you have a second, if you have any questions, please note that those coordinates. I'm happy to answer questions at any and all times, especially if you have questions after this webinar. It's going to be a very, very fast-moving webinar, so I'm happy to entertain any questions afterwards. A little bit about me. I'm the author on 4 different books on Spring, lead author or main author. Did a video series. I go around the world talking to people about Spring, and so this is very much what I love to do. I'm also the leading contributor of bugs to many fine projects at Spring, like Spring Integration and Spring Batch. And, again, I'm out there. So if you have questions, let's carry this discussion forward on Twitter afterwards, or, of course, we can do so here in the session itself. So, first, and by the way, the thing at the bottom there, that's kind of interesting, Pivotal. So I don't know how many of you guys realize this, but the Spring team has a new home. We're now part of a new company called Pivotal. We started it in April. We, along with the Tomcat, the Grails, the Redis, the RabbitMQ, and Grails and Cloud Foundry teams are now part of this new company focusing on building a better, programmer-facing, programmer-centric platform. We also have a Hadoop distribution called Pivotal HD, which you can get. And so, again, we're trying to build a platform that is layered on top of the cloud. It's cloud ready. It's big data ready. And, of course, at the Spring is the glue, the component model that glues all this stuff together and simplifies it wherever possible. Spring, of course, is where developers want it to be. It's where they want to run their applications. So a lot of people start with one particular API or one library, and they start focusing on just building web apps, or they focus on just doing big data, or they focus on whatever. Well, it's easy to get into that sort of tunnel vision, and forget that Spring is actually, more than likely, there's something there to help you. So looking for the answer in terms of the Spring platform can actually be very helpful. You can save a lot of time. More than likely, there's something there that can get you started. To help with that search, to help better categorize our technologies, we've come up with this logical grouping called Spring I/O. So Spring I/O is our platform. It's what we're describing, the platform. At the top there, we have the I/O execution layer. The execution layer describes the vehicles we imagine people are going to use to begin with the platform, right? And they also describe things in particular that have a process. So Spring XD is our turnkey big data, appliance. Spring Boot is our attention-focusing framework for building Spring applications very, very quickly and based on convention over configuration. And Grails, of course, is our rapid application development framework built with Groovy starring Groovy. And then once you've entered the platform through one of those vehicles, one of those channels, you can take advantage of the APIs and libraries underneath them. For example, those that support integration or batch or big data, etc. Of course, common to all these different types of disciplines and applications is the need to work with data, be it relational or non-relational, be it NoSQL, not only SQL, new SQL, etc. And Spring features first-class support for all of that. So again, this is something you're going to likely work with no matter which layer of the stack you're dealing with. And then, of course, underpinning all of this are core concerns like Spring Framework, of course, the core Spring Framework, which underpins everything, and the Spring Security Framework, which, again, you can see that layered across the entire platform. It's a cross-cutting concern, so it's very easy to use across everything. As part of our new adventure at Pivotal, and as part of our efforts this year to really, really simplify the getting started experience for Spring developers, we've got a new home on the web. It's http://spring.io. This is the new home of Spring. If you go to springsource.org, the old website, it'll just redirect to this. It's I hope you'll agree, vastly simplified, vastly better experience for developers, more in line with what a lot of developers are expecting these days. Of course, you've got the usual suspects. You've got the blog and the project pages and so on there. Documentation is far more readily accessible and usable. It's much more intuitive to navigate the documentation and find out the latest and greatest releases of projects and so on. But one thing I really like are the guides. If you've ever wondered how to get started, or if you've got team members that want to get started with Spring, point them to these guides. These guides are each 10 to 15 minutes long. They're backed by by a GitHub repository, and each repository contains both a complete working example as well as an initial directory structure, which just contains a build file. These guides are 10 to 15 minutes long in duration. They should be something you can do at lunch. Ingest data and ingest nutrients for your mind and for your belly, right? So these are very, very task focused, right? They're not written in terms of a technology boundary. They're written in terms of a task that you might want to do. So if you want to work with a database or handle messaging or integrate with Twitter or Facebook or deal with a NoSQL data store or write a REST service, again, you'll more than likely find a guide. And we're adding new ones all the time, so check back as often as you can. Spring IO, of course, is, I should mention the blog. The blog is another thing that, a lot of people don't realize that we used to have blog at springsource.org, and we used to have the news feed on the front page at springsource.org, and there were actually two different channels. Eventually we consolidated it, but if you're me, and you're looking at that, it felt kind of like a sidestep, it felt like a Band-Aid. So now we actually have one blog feed, and it's guaranteed that if you're reading the blog, you're going to get all the good stuff, as well as some marketing stuff, of course, but what else would you have us do? We need to have some marketing, right? So all the good stuff is on the blog now. Definitely subscribe to it. You have one feed, one destination for all the latest and greatest content. And, of course, I put together and often in conjunction with a lot of people from the team, but there's a This Week in Spring that we do every Tuesday, which aggregates the latest and greatest content, community videos, tutorials, etc., whatever, anything, slides, tips about Spring every week, every Tuesday. Spring.io, the website, is actually an application built using Spring. So it's a proof point for us. We're going to open source it and make it available. It demonstrates a lot of the sort of best practices surrounding contemporary application development. So we're building on top of Spring, and of course we deploy in Cloud Foundry, the open source platform as a service from us, from Pivotal. We're using GitHub. We're using open web technologies like GitHub, for example, and modern tools for managing the application like Splunk. So expect to see that code drop fairly soon. The place to look for it, of course, is going to be on GitHub. This is an important part of what I hope you'll take away from this is that all of our projects are on GitHub. They had been for years, but it's just sort of, people ask me, well, how do I get started? How do I contribute to one of the projects, Just send a pull request. It's right there. We have a very active contribution model, and we're always happy to have more pull requests and more feedback from the community. That's how I got started, was, sending a pull request, or actually it was Subversion at the time, but sending a patch. But it's a very good channel for anybody who's looking to have their say on the direction of the frameworks. Okay, so what we're going to do today is we're going to look at a lot of the new stuff. This is a smorgasbord, which is a Swedish word I discovered recently. It's a smorgasbord of the different stuff coming out of the Spring team in the last year, right? So it's not going to be a deep dive. There are a lot of great resources, and I'm sure we'll put up links for all the deep dives, for lots of different deep dives for each of these technologies when we put the video up on SpringSource, on youtube.com/SpringSourceDev. But we will ever so briefly touch on something and then move on, okay? Let's start with Spring Boot. Spring Boot is a way of focusing attention on that which matters and when developing an application. We have several different, vectors where we're doing this. One, for example, is we deployed a set of POMs, Maven project descriptors that have aligned versions. So if you want to do a web application and you want to use Spring, just import that one POM, and it'll give you a well-known set of configured APIs that work together. And these aren't just optional dependencies. These are what you're going to need in practice, not just in theory. And so you can get started very quickly with just one Maven dependency. Another thing we've done is we've provided a way to work with Groovy-based code, and we've provided a command line tool called the Spring command line tool. You can install this command line tool by using Homebrew, for example, or just installing it any way you like. But the result is that you can actually write code like this, which is tweetable, which is awesome. It's actually a Spring MVC REST service that you can start. You just say Spring run and then name this file, and it'll actually look at the class, determine that it's a Spring MVC controller, and then based on what it assumes you need, it'll start up Tomcat and start up the web server for you. So again, working REST in very, very small amount of time. Let's take a look at that, okay? This is a slightly more modern example than that tweet, but same idea. So there's a REST controller, and it's got the grab annotation at the top. All I'm doing is I'm returning an object that has a message, and I'm going to use the Spring Run service.groovy. The grab annotation is a way of doing dependency management like Maven for Groovy. So it's pulling down a library for us. Based on the presence of that library, Spring Boot will provide services for us. So of course the REST service itself is working, but also we get all this great stuff like the dump endpoint, which gives you a dump of the current stack frames, the env endpoint, which gives you a look at the environment as it stands right now in the application, the metrics endpoint, which gives you a count of how many requests have gone into each endpoint that we've exposed and so on, and then of course the beans endpoint, which gives you a kind of a JSON dump of the application context as it is right now. Of course, you can secure all that stuff, but I just think it's really, really neat that that's all kind of included out of the box, optimized for development, optimized for production. Of course, all this stuff is great, but, not all of us are Groovy programmers, and that's fine. Spring Boot is not by any means a Groovy exclusive technology. It works great for Java as well. If we're going to do Java, though, we should probably do it inside of a tool that makes sense. So let's take a look at using Eclipse. This is actually STS, the Spring Tool Suite. It's our open source Eclipse superset. We're going to use a file new Spring Starter project wizard and just check a few boxes and put in a few packages, and it's going to give us a pre-configured application with a POM and everything we need. And this also uses Spring Boot. So the application itself is, rather Spartan, but again, it's everything you need to get started, including a basic entry point like this one, Spring application.run. This is a Spring Boot annotation at enable auto configuration at the top. Again, you could get the same thing by going to the web service, start.spring.io, and just filling out the information there. It'll let you download a zip file as well if you're not using STS, or if you're not using, this iteration of the STS. Another thing that you might want to do is actually follow along with those guides, right? I mentioned the guides just a few minutes ago. They're also accessible inside of STS. So go to File, New, Import, Getting Started Content, choose the guide you'd like to follow, and specify whether you want Maven or Gradle, specify whether you want the initial or complete working code base, and then hit Import. And then the project will actually, it'll set up everything. It'll pull down the code, set it up inside of Eclipse, and then you can follow the guide and follow the steps as you like. So again, a very, very good way to get started. And of course, all these guides, wherever possible, are implemented using Spring Boot. So if you're looking for, a really, really good, well-narrated way to get started and keep going forward, Spring Boot is definitely, I think, it should be at the top of your list for things to check out. Of course, this is just a regular, Spring Boot application, and we're optimizing here. So you can deploy a Spring Boot application to legacy application servers like JBoss and WebLogic if you like, and to more lightweight environments like the cloud or Tomcat. But again, for development, for getting started quickly, might as well just run this locally. So the application class is just a public static void main. I suppose I got cropped off here, but I ran and I right-clicked on the class and I selected Run as Spring Boot application. It just launched Spring Boot, and again, just as we did in the Groovy code, Spring Boot saw that I have a Spring MVC controller, and it's started up the application and Tomcat for me, based on the presence of those libraries on the class path. Not bad. Another thing I want to just sort of drive home is that Spring is very much a JVM, a first-class citizen of the JVM, not just Java. Spring and all the portfolio projects support multiple versions of the JVM, and we've always done that. I mean, for example, Spring 3, which was released in 2009, so a few years now, but Spring 3 supported everything up until Spring 3 supported Java 1.4, a language version that had been irrelevant for 10 years, even almost by then. And now, of course, we have great cross JVM compatibility as well. So the new Spring 4, for example, supports version 8, which isn't even out yet. We also have support for other languages like Groovy and Scala, etc. A lot of people don't realize this, but Spring is not just XML. It's a further thing from it, in fact. We've had good support for working with Java configuration since 2005 when we debuted the Spring Java config project. That project was then merged into the core in 2009, And since then, we've built on that across all the portfolio projects, providing Java configuration bindings and APIs. In addition, we've got Scala binding. So for example, here's a functional configuration base class that defines, and you can see we're using the functional configuration base class in a Scala, in an idiomatic Scala way. We're defining beans, right? Again, remember, Spring doesn't care how you tell it about the beans and the relationships. You just need to tell it somehow. So you can do it through a XML, you can do it through Java config, you can do it through Scala, as we are here. You can do it through the Groovy bean builder, which is also inside of Spring 4. You can do it through Java configuration, right? So here's actually a Java configuration class that most of what I do these days is I start with Java configuration. So it's very, very concise. And with Spring Boot, as often as not, you don't even have to do this, So here I've got a configuration class. I'm importing another configuration class. The configuration class is passed to the annotation config application context, just like you might an XML file to the class-path XML application context. And the beans annotated with @bean, the bean methods, the bean factor methods, if you will, that are annotated with @bean, return a object, and that object is what's stored in the context and made available for injection and so on. So each dependency that I need, I can either invoke the factor method directly, or I can declare an argument, including, and I can even do things like @qualifier that type. So I can say I want the data source, but I want it only the one who matches this @qualifier binding to get specific, to disambiguate if you have multiple beans of the same type. You also have, access to the usual suspects. So, for example, I want to do the equivalent of tx:\annotation-driven. That's @enable transaction management. I might want to do, to search for beans in a certain package. I can use @component-scan. Again, all these things work as you'd expect them to. Now, one thing I really quite like in the new Java release is Lambda support, right? Lambdas or closures or whatever you want to call them. This is a feature that we've been missing for a long time. Not to put too fine a head on it, but a point on it, but even C++ has Lambdas. C++, of course, is a language whose governing body meets every few years, if that, to talk about updates, and they still managed to deliver Lambdas before we got them. So I think a lot of us are ready for this. It's going to be quite nice. There's actually a Java 8 developer preview that's available already, and it's API stable, at least, right? So you should be able to download that now. It's already been available for a month now as of this webinar. And that preview is, like I said, it works great. You can use the language features already. IDE support is a little bit less rosy, right? So if you look at Java 8 support, IntelliJ has already had good Java 8 support for the last year. Eclipse proper won't have any until June of next year, after Java 8 has been released, which is a little disappointing. But our tool suite, the Spring tool suite, has preliminary beta Java 8 support, and that, of course, is Eclipse-based. So hopefully that'll tide you over, As I mentioned, Spring 4 is to be GA by the end of this year. I'm going to GA against the Java 8 developer preview. So definitely check that out. It's a great combination already, and there's a lot more to come. One thing I like are method references. This is powered by by the so-called functional interface. So here I've got a method, private customer map, which takes a result set and then row num. Well, I can reference that method any place where I would expect an instance of the Spring row mapper interface, because a row mapper interface has a method, has one method inside the interface, which is map from result set and row num to an object of type T. Well, in this case, T is customer. So that method, even though the name may be different and the visibility may be different, it can be slotted in substitution for that interface type. So wherever you see that, then you can use those method references in your Java code. So here I'm using the JDBC template. I'm saying query for objects, passing in a query, and then passing in this : map, which references my method reference. Even better, you can use anonymous or inline method references, lambdas, right? So, and of course with Java 8, you have type inference, much smarter type inference. So here I can drop off the types, and I can just say RS and then row num, and it returns a new customer. The there's a lot of benefits here. First of all, it's good for we developers, save on spacing and typing and so on, and of course we get the benefit of more, self-evident code. You don't have to look all over the code base just to find out what's happening. But in particular, for people like me, this is the first time in a long time where we've had tweetable enterprise Java code, and that's a big deal. So yeah, good stuff. Java 8, of course, brings with it a host of new improvements and APIs like JSR 3.10, which is based on Stephen Colburn's Joda time API. So it's nice to have that actually supported in the main JDK, and of course we have great support for that in Spring 4. The JSR supports bean validation and binding. The support in Spring based on that the JDK, JSR, supports bean validation and binding. Of course, we already support both the native java.util.date and we support Joda time itself in Spring MVC and all throughout the framework. So this is actually just the third option you have for doing this kind of stuff. But again, we're on top of it. Repeatable annotations, a new feature in Java 8 that makes it, that lets you do more expressive things with the language, are now well supported by the framework itself, wherever appropriate. And so I think really there's a lot to offer. But let's move on. We got to move on. So let's look now at web services and web development with Spring. Let's take a look back to a time long, long ago where dinosaurs roamed the earth and we were dealing with green screens and amber screens and Internet Explorer, the dumbest clients in the world, right? This is what dominated most of the memory of computer science that had to do with interaction or user interfaces, are these dumb green screens and then fairly dumb Internet Explorer. These browsers set us back, and these clients set us back as a community for a long time, because we had to build applications that had no real smarts on the client side. There was no way to build really rich interactive applications in a ubiquitous kind of way. All the smarts, even the component in the UI state, lived on the server. These clients couldn't render themselves very much. They could do basically what the server told them to do. There wasn't really a lot of room for the dynamic type of applications that we would have all liked to have seen built at the time. Eventually, of course, we leveled up the community itself, and we now have things like HTML5 and the whole platform there, the umbrella. We have really, really smart JavaScript engines that live in these browsers today. Even Internet Explorer, to its credit, has caught up with 2006 and 7. So it's really, really come a long way, and we can do things now in JavaScript that I wouldn't have thought possible. Did you guys know you can boot Linux? There's actually a project. There's a Fabrice Badal. He built a Linux emulator in JavaScript. So again, the problem is no longer that we have dumb clients. It's that we have really, really smart clients, and there's no reason to do anything except for the basics of state transmission back and forth between the service and the client. So that begins the question: what do we use to communicate state? We still have to have some state on the server, and that of course is business state, entity state. Your domain model. REST is by far the most prevalent way of exposing that state today. Right? It's become the de facto standard for web services, and I know it may be a bit premature, but I would say it's given us what we were all hoping to achieve with SOA. It's a beautiful thing. So REST, for those of you who don't know, is basically a big hug for HTTP. It's a style. It's an architecture principle set forth by Roy Fielding in his doctoral dissertation in 2000. It describes an architecture based on idiomatic HTTP. So, for example, if I want to retrieve a resource from a server, I use an HTTP GET. If I want to delete a resource on a server, I use an HTTP delete. If I want to update something, I can just put it. If I want to insert it or something, I can use post. And of course, I can use native HTTP headers and status codes and things like that in the platform. So instead of sidestepping it, I'm actually embracing HTTP. The problem, of course, is that REST is a style. It's a design style. It's not so much a standard or a spec that you can read. So you find in wild, APIs with varying levels of compliance with RESTful principles. A lot of maybe sort of misleading APIs label themselves as REST when they're anything but. So to sort of address this problem. Dr. Leonard Richardson created what is now called the Richardson maturity model. In it, he provides 4 levels for grading the compliance of a given API with RESTful principles. Level 0, of course, is the swamp of POX, which is a great name. In this example, you may have an API that uses HTTP, but it could be it is in some sense just accidental. It's an incidental even. So SOAP is a great example that comes to mind. SOAP is, in principle, in theory, it runs on top of HTTP, but it doesn't need to. People don't know this, but you can actually do SOAP over JMS. You can do SOAP over, any other protocol you want. It doesn't have to use HTTP at all. So the fact that it uses HTTP is accidental. It is not. There's nothing about SOAP that is native to HTTP at all, and that's why a lot of people who are looking at SOAP think, it's not a particularly great way to use the web. It's kind of an abuse of the web. Level 1 is resources, right? So this idea is you're using HTTP, and you still may be using it incorrectly. I mean, you might be funneling RPC style commands through the URI, but you still now are at least distinguishing different entities, different nouns in your architecture in terms of unique URIs, right? So you might have an articles endpoint or a customer's endpoint or whatever. Level 2 is a great place to start. Level 2 is, you're embracing the native platform. You're embracing HTTP idioms like status codes and headers and so on. And if you do everything wrong, this is where you start up with Spring MVC. So even if you do everything wrong, you still end up at level 2 out of the box with Spring MVC. Of course, Spring MVC is our framework for building web services and web applications. Basic MVC model, so requests come in, hit the dispatcher servlet, which sits at the edge of your application server. Requests are forwarded to controllers, the beans that you write, where they can then process the request, do things like set up state and package that state back into something called a model. The model gets sent back to the servlet, which may then either render the model directly, as you might in a REST service, for example, or perhaps delegate to a view or even further to a view resolver, which then finds a view to render a template. Here's an example of a REST controller built using Spring MVC. This is a class that has a REST controller annotation on it. We've got a request mapping annotation at the top stating that every method underneath the controller, inside the controller, is a child of the URI described in the class level request mapping annotation. We can also specify global things, like we can say that all of these endpoints will produce application JSON. You don't have to, of course. Normal content negotiation rules apply if you don't bother specifying a specific content type, and that's fine, right? Other than that, this is fairly. I hope this speaks for itself. I mean, you've got a delete method which takes a HTTP delete request for any endpoint, any call going to users / and then some sort of ID, so maybe 5, for example. And if it's a type of HTTP request of type delete, of the method delete, Spring will call this method, pass in the user path variable, which is what that curly bracket bit is describing, and then attempt to coerce it into a type that you've expressed interest in your arguments, in this case a long, and then pass that to you. So your delete method will be called with a user value that was passed into the URI. You can then do whatever you want with it, including returning types, domain types like the user. Spring MVC will attempt to render that user, which is just a POJO. You don't have to do anything to adapt it to Spring MVC in particular. Same thing is true for the GET endpoint here, for example. Now, here's an example of a RESTful service that I built that is backed by a user account table. This is just fictitious, nonsensical sort of data. I'm going to go to the users / one endpoint. You can see I've got it's a JSON representation of that data that's coming back. I can use the advanced REST client here, which is a Chrome plugin, by the way, if you're interested. There's also a great one called Poster for Firefox. And I can interact with the resource very, very easily, right? So it's just HTTP after all. I can also do things like delete it, and so you can see that record is now gone because I've successfully deleted it, and it's gone in the database as well. Of course, if I go to another endpoint like 5, I can bring up other endpoints. For example, here's one that actually just renders an image, right? Here's one that actually renders a collection of records underneath the resource. So that is fine. I mean, it's definitely a good start. Like I say, if you do nothing else, at least make sure your API complies with level 2. That's a fairly restful, approach, but we can do better. There's a couple problems with level 2. First of all, your API isn't particularly self-documenting because you have to know where the deep links are. You have to know what API endpoint to hit to achieve a certain result. In a sense, your API is the URIs, which is, in theory, that's fine. But again, for long-lived applications, in order to promote more flexible APIs, you often want to decouple your URIs from the actual behavior, right? This is commonly handled different ways. Some organizations try and use things like versioning, but again, that just puts the onus on the client to adapt, right? So if you can make it so that calling an endpoint gets you the latest and greatest version of an endpoint, for example, that way you're always using the latest and greatest, and you're moving off of the old ones because you don't care about the URI. You just care about the what am I trying to achieve, right? So to do that, you need to express metadata about the API itself. There's a pattern called HDOS, which is almost unpronounceable. It's hypertext is the engine of application state. It is an approach to implementing hypermedia, or to taking advantage of hypermedia. What does this mean in practice? Well, it basically just means taking advantage of the link construct, right? You can encode a link as JSON or as a XML. So here I'm using a standard XML, HTML encoding for a link. You might recognize this from HTML when you link in a style sheet, CSS style sheet, right? It's the same thing. You've got an href, which is the URI, which isn't that important again, and then you've got the rel, and this is actually the API. The rel is what's important. It's the relationship. It's the relevant relationship. Both are great mnemonics for remembering a rel. That's the part you want to care about. So as long as you, as a client, see that you have a link for the customer's endpoint, who cares what the href is? Just as long as the rel stays static over time. So Spring HDOS is a project that layers on top of Spring MVC. It makes it very simple to build HDOS compliant solutions. So here's a Spring MVC controller, the ref controller, same as before basically, except that you'll notice in all my endpoints, instead of returning a straight user, I'm returning a resource of user. So it's an envelope, and that envelope contains links and the payload, the user in this case. The recipe for converting from one user to a resource of user, or any other type to a resource of that type, is usually encoded in something called a resource assembler, which is a Spring HDOS interface. So here I've got an example of the resource assembler inside of Spring HDOS. Again, it's typed to user and resource of user, and the result is it's nothing particularly fancy. I'm just building up a resource object, passing in my payload, and then the real interesting stuff is in the creation of links. I'm using the fluid DSL that Spring HDOS provides to introspect at runtime the at request mapping information on the controller classes. So I say link to method on user profile photo controller, call the method on the controller, because what I'm giving back is actually a proxy, right? It's actually a stub for that actual controller class. So I can just invoke methods on it as I like. And then Spring HDOS will see that I've invoked that method, and it'll take the request mapping information and dynamically build the URL for me. So I don't have to munge strings to build up these links. I don't have to repeat myself, etc. Very clean way to go. And of course, I put that all together in that resource in the bottom. Here's an example of hypermedia. So I'm going to, again, the same idea. I'm going to select from the database. I'm going to look at my user account information. I've got a menu here. The menus of, again, the first endpoint when I come into the app is just links, right? It's actually, if I want to go to the users collection, here's the relevant href. If I want to go to the customers collection, here's that. I can dig deeper, of course. My users endpoint, all of the users are now available to me. And of course, I can get access to the rels that are relevant for each record. So if I want to find out the customers and the photo and all that stuff, I need to only ask the links. I don't have to guess anymore. Again, each sub payload has all this stuff as well. And again, even this, I can return back I can send back binary data, but in the headers for that, I can send back a link. So this HDOS principle is very great for sort of easy to traverse data. And in fact, to promote that easy to traverse nature, we actually have the Spring REST shell, and you can easily install this on Homebrew. just do brew install rest-shell after you've done brew tap /pivotal. The REST shell lets you interact with hypermedia APIs like this one. And mind you, there are different styles, but ours is fairly common. And we support different ones like HAL or HAL. And you can use the REST shell to kind of navigate your API like it was a directory structure. So here I'm going up and down, I'm descending into a low level, and I can actually use the discover command here to get that pretty printed table of links, just like I did in the JSON itself. So again, I can really easily get a feel for what each API can do. And the nice thing about these links is that they're dynamic, right? I can return links according to what I'm doing and according to the state of the application. For example, I wouldn't want somebody to try and call the refund endpoint in my CRM or my order management API on a order that hasn't been officially checked out, that they haven't paid for. Well, there's nothing but guidance and documentation to tell a user of a regular API that is so. But with a hypermedia aware API, I can send back a link saying, here's the refund endpoint, which wouldn't be available if the order wasn't actually checked out and already paid for. So again, those links provide a clue of, applicable operations, of relevant operations given this resource. That's REST. That's a great way to do poll style communication with the service. It's the client initiates the discussion, and then of course, the server sends back the response. For server-side communication initiated from the server, sent back to the client, you need something more dynamic. Spring supports WebSockets. We support the relevant JSR 356, but we offer support that far exceeds that. So, for example, sock.js, there's a couple reasons to exceed it. First is compliance with older browsers. They want to be able to offer them a useful experience as well. And then second of all, you need a more natural paradigm for building applications on WebSockets. Sock.js is both a client and a library, and a client and a server protocol, and Spring MVC supports that protocol in Spring 4. It is a superset of WebSockets. So if you're using WebSockets, it will support WebSockets. But if you don't have WebSocket support in your browser, you can use the Sock.js client, and it will transparently fall back using other types of protocols and paradigms for communicating with a server. And then on top of that, we actually provided support for Stomp. Stomp is a lightweight messaging protocol, and we've actually built great support for handling that inside of Spring 4 and Spring MVC. And this support, by the way, is modeled in terms of the Spring integration messaging type. So we've actually moved core interfaces into Spring Core. So now messaging is, well supported there. And if you're used to Spring integration, then this will seem very natural. To build a WebSocket application is fairly simple. Here's a Spring MVC controller, and the controller is it's got two different methods. One to handle a message that's sent into the application. So, for example, if somebody from a WebSocket client sends a trade object, then I can let Spring MVC handle the trade at the app/trade endpoint. And if I want access to the javix.security.principal, which is provided by Spring Security in this case, I can have that as well. And then, of course, I can just pass that trade on to some sort of service and deal with the trade however I like, right? The opposite use case is, what if I want to subscribe to a destination being serviced by something Spring MVC is providing? What if I want to retrieve all the updated positions? Well, I can respond to that event as well with the @subscribe event. So here, the client makes a request. I can get access to the principal again. Perhaps initiate the discussion with them, save them, whatever, put it in the database, and then I can send back the initial set of positions as well. So here's an example built by Rossen Stoyanchev. Rossen is a Spring ninja and all-around great guy. He built this Spring WebSocket. I think it's called the Spring WebSocket Showcase. I've been logging in two different sessions, right? So the first one was one client, and the other one was a different one, and I can make changes on one and see the changes in the other. So of course this would work if you guys run the application yourself. You'll actually see it work across the network on it. It does not benefit from the fact that I'm running both on localhost. So I'm going to go ahead and sell 10 shares of Dell, because, wouldn't you? And instantly you would see the update on the other screen. Similarly, I can go back to the other side and make a change there and maybe buy something. Again, these are not actual stock values, so please don't use this to advance your portfolio, okay? But anyway, yeah, you see the point, right? It's very easy to get interactive applications very quickly. Today, of course, building your own REST API and building your own WebSocket-based API is one thing, but it's a very connected world, and as often as not, you need to use other people's API. And this is a good thing. There's a lot of great functionality out there, and your users, more than likely, are already using other services. So if you can build an application that is integrated with these other platforms, these other services, then you can build value into your own application. Remember, things like Instagram, I mean, I'm pretty sure most of you have used Instagram, and we've seen it before, and we all know it's, fairly unremarkable. The only thing it has going for it is that it builds on top of Facebook and the Twitter ecosystem. It builds on top of a niche that wasn't already served by those platforms. The users came for free, basically, because they built on top of that huge, huge platform. And you get that same benefit, too, as long as you know how to integrate. I show here that Pinterest is, very, very active. Did you guys know that Pinterest is number one provider of referral traffic above Facebook and above Google Plus and above Twitter combined? That's a hard thing to turn down, having that stream, Of course, they just announced just recently, like in the last week or so, that they have an API as well. And that API, of course, is not yet, we don't have a binding for that just yet, but I'm taking bets as to when somebody's going to build the first Spring Social binding. So Spring Social is a API to connect you to these different service provider APIs. I don't know how many of you have had the dubious pleasure of using Facebook, but on Facebook they have this fantastic thing I'm really quite enamored with it. It's called Farmville, and as I understand it, and again I'm not an expert on these sort of things, but my understanding is that it's just for spamming people. It's an amazing engine designed to spam everyone all the time, and you can participate. You can access this amazing technology yourself if you like. You just go to the Farmville web application and you click on install, and it'll install this amazing spamming machinery. But first you have to sign in if you're not already signed in. So it'll prompt you, do you want to sign in? And of course then you'll say yes, and you sign in. Then it'll prompt you, do you give Farmville permission to spam your friends, family, and loved ones mercilessly and endlessly? And you have to click on OK. Okay, so once you've done that, Facebook will send what's called an access token, ultimately, back to the Farmville spamming machine, and then they will have access to that access token. It's like a cookie, and that cookie gives them the ability to talk to the Facebook API on your behalf. It identifies the requests coming from the Farmville spam engine as belonging to this one particular user. And that dance, that exchange is called the OAuth protocol. Okay, OAuth is, as you can imagine, fairly hard to get right. There are 3 different versions of it: 1.0, 1.0a, and 2. We make it a lot easier to use it and to take advantage of all these different service provider APIs with Spring Social. Out of the box, they support GitHub and TripIt and LinkedIn and Facebook and so on, and Twitter. But the far more interesting story for me is all these great bindings from the third-party world, all these great open source community contributions. So here are just a few of them, and again, I wonder how long it'll be before we see a Pinterest binding listed there. These are all third-party bindings that support different APIs. The one story I like to tell is of Google Plus. As soon as Google Plus the API was announced a couple years ago, within a week or so, there was a Spring Social binding. So again, the community really engendered the awesomeness here. To use Spring Social in your code, it's, again, configuration is fairly straightforward. You just check a box, basically. You add the @enable * annotation that's appropriate. In this case, I'm going to @enable Facebook and Twitter and LinkedIn. And then you specify the app ID and an app secret. These are the credentials that you get from the developer portal for most of these services. And then from there, Spring Social will, whenever you try and use the binding, trigger the OAuth dance for you. It'll make the call to the service provider and attempt to get that access token if it doesn't already have one. And then you can use these API bindings, these typed bindings on top of the core OAuth and authorization and authentication machinery. You can use these bindings like the Facebook binding here, just as you would expect, right? So I can say Facebook friend operations, give me my friend profiles, or, I can update statuses, I can do tweets, etc. from the Twitter binding. If you want to learn more about this, of course, there's a great demo from from the Spring Social project. Here's the Spring Social showcase. I'm actually using the sign in with Twitter thing, so I'm redirecting to Twitter, getting most of my information, and then I just have to provide a password to sign in and complete the authentication. And then once I'm in the application, I can bang around. I can hit these different endpoints and see what's happening with my account. Right? That's really, really powerful. We have the ability here to work with the API, and it's fairly painless from your perspective. That's a good thing, TM. Of course, if you're building a web application today, you can't ignore mobile. Mobile is a huge destination for your applications. There's a lot of Android and iOS clients, of course. If you look at this graph from IDC, it shows that in the second quarter of this year, there was nearly 200 million units of Android shipped. So I would certainly build the Android and iOS native clients first. But you can't ignore the other types of clients either. You've got to build useful experiences to them as well, right? Even Windows Mobile. And of course, if I'm putting together a team, I'm judging the cost-benefit analysis of whether it makes sense to build a native Windows Mobile app versus just building a web app that is optimized for Windows Mobile. I'm probably just going to build a fall-to Windows Mobile app, a web app that works on Windows Mobile as well as all these other devices. So Spring Mobile makes it very easy to do that kind of thing, and Spring Android in particular gives you the Spring REST template, which is what we've seen in Spring Social, and that's what makes calling into REST APIs very simple. It gives you the REST template. It makes it dead simple to use anything you can imagine doing with REST from the client side from a native Android application. And this includes using Spring Social bindings and using the clients, Spring HideOS clients as well. So there's a lot of power there, When we talk about building Spring applications, of course, there's Spring has got it's very famous because it's so portable, It works on many different environments, many different containers. It works, of course, in sort of legacy application servers like JWAS and WebLogic. You can take advantage of all the features there. And in fact, if you're trying to build an application that works in Java EE, Spring is by far the safest way to go because it knows about all the inconsistencies in the spec. So, for example, JTA is something that is surfaced in different ways depending on which part of the API you're trying to use across different application servers. But with Spring, it's just one API. We support Java EE7 in Spring 4, of course, so the daytime API and the updates for JTA, JMS, servlets, and WebSockets, and etc. and bean validation are all there. The new APIs like WebSockets and the concurrency API, of course, are there. And we in the Spring team even participated in a few of these JSRs. So the WebSocket JSR and the Bash JSR, for example. So yes, we support a lot of the new stuff from Java EE7, certainly. Of course, Spring works very well in the cloud. I would be remiss if I didn't mention Cloud Foundry, which is from Pivotal, but we also work on other cloud providers. So Cloud Foundry is a great place for your application, but Spring works just as well in Google App Engine. Well, perhaps not just as well, but it does work on things like Google App Engine and other providers as well. That's uniquely something that's unique to Spring. Is very, very portable. The way we can do this is we use something called a profile. Profiles give you the ability to say, I've got a set of beans, and these are specific to a certain environment. So here I've got a cloud profile which demonstrates you creating a data source and binding that data source using the Cloud Foundry specific API, but I can create another configuration class that perhaps resolves my data source from JNDI and get another one which uses an embedded database or whatever, for Q&A and iteration testing, unit testing. So this makes it easy to build apps that work portably across different containers. Of course, by far, the most common container today is Tomcat. This, of course, is just one data point. It's the zero turnaround developer productivity report from 2012, showing that, and again, there are multiple choices here, but even with that in mind, there's no single larger, more represented application server than Tomcat. And the number 3 most well-represented application server, of course, is Jetty, both of which are just serverless containers. They're not, they're much lighter weight than anything else in the list here. So that's a validation, I think, of Spring, right? This is a great place for Spring. When you're working with web applications are certainly what a lot of people start with, but those of us who have built any kind of serious application, we know that it's not all just the web. There's certainly a lot more to it than that, and of course, as often as not, these pieces don't work well together. integration is very hard to get right. There's a great book by Bobby Hope and Gregor Wolf called Enterprise Integration Patterns that describes the numerous patterns that people have developed over the years for building integration solutions. Spring integration is our framework that models these patterns. Here's a simple integration configuration file. So I've got 4 components. You can see the 4 stanzas. The file inbound channel adapter says, send a message whenever a new file arrives in the user my home directory on my desktop in my in folder. And then whenever a new message arrives, send it to the transformer component, which will take the file object that we got from the inbound channel adapter, and then create a Spring Batch job, and then it's going to forward that to the service activator, which is the 3rd component down. Service activator is just a escape hatch. It's going to call a message with the payload of the Spring Batch job and actually launch the job for me. And the results will be sent on the job executions channel. Again, a channel in this case is a little more than a Java util.q, but you can back it with things like a JMS destination. And then it's going to be sent on the job executions channel to the stream standard out channel adapters, which just basically writes to standard out. But again, you might send it to something like syslog or Splunk or a database or whatever, a file system, FTPS, who cares? So integration is much easier to describe inside of Spring integration. It's a more natural way to think about complex orchestration. I mentioned that this example uses Spring Batch, and we've talked about Spring Batch before. Spring Batch is a great way to avoid idle computing resources. Batch processing, of course, is something that's been around since time immemorial. Spring Batch is very much the inspiration for the new JSR, but the JSR is a very, very small subset of Spring Batch's full capability. So definitely check out Spring Batch if you can. The anatomy of a Spring Batch job is such. Jobs have one-to-many steps. Each step has a reader, an optional processor, and an optional writer. Typically, you're going to use a writer and a reader that's provided by Spring Batch, something to read from a file system or a large XML document or a large CSV file or database or whatever, and then work in chunks, right? So each step models one input-output step. Once you've launched a job, you get what's called a job instance. The job instance then can be asked for a job execution to kind of get a feel for how far along in the process the job is going. All of this is backed by metadata stored in a database table. And of course, you can ask the question, how far along are you? It might be a week. It might take 10 days. Who knows? It might be 10 hours. So it's good to have this metadata available. And Spring Batch is smart enough to retry, and it can configure to restart jobs and so on. Here's an example of using the Spring Batch Java Config API. The Java Config API here describes a job, and I'm injecting the job builder factory. And the job builder factory provides a fluid DSL, which I can then use to string together my steps. In this case, I've only got one step, S1, which is actually the CSV to RWMS step. Sorry about that. And then I can say, okay, after the step finishes, end it, and I build it. And then below, you can see the definition of that one step. But again, you might have as many steps as you need. Each step takes an item reader, an item processor, and an item writer. And these are, again, things you'll configure elsewhere. And I can use the fluid DSL here to build up my step, programmatically very quickly. So it's really just about assembling the pieces, the batteries that come out of the box. Here's an example of me working with a database which has customer records in it, nothing in it right now. I've got a CSV file with some 10 records in it right now. I'm going to go ahead and launch my Spring integration job. It's going to monitor a directory for new files. And then when those new files arrive, it's going to launch my Spring Batch job, which reads the data in the CSV file. I'm only using 10 records here for convenience, but again, you might imagine, 100,000 or a million records. Again, Spring Batch is ready for big, So I'm just watching the output here, but you can see it's already run. So I've got 10 records in the database there. If I go ahead and go back to my directory and actually just rename the file, make Spring Integration think that a new file has arrived, the records will be processed very, very quickly, and you can see the results already in the database. Batch, of course, is a very good way of dealing with large amounts of data, but there's more under the sun than just SQL. So a lot of that is described by the NoSQL movement. NoSQL, not only SQL, new SQL. And these are specialized data types, specialized data storage technologies like Redis and MongoDB. Neo4j, for example, is a graph database, and it's infinitely more suited to modeling things like the Facebook friend graph, for example, than a SQL database would be. So it's not NoSQL doesn't have to be about no SQL. It can be SQL and then something else where appropriate. Here's an example. One of my favorite features from the Spring Data project, which provides the bindings for these different types of NoSQL stores, is the ability to define an interface. And these interfaces provide you finder methods or query methods based on convention. So here I can say, find all the users in my backend SQL database using JPA in this case, or MongoDB if I wanted to, or GemFire or Neo4j or whatever. Find them all based on the parameter here. And again, Spring Data will implement the interface entirely based on convention. So it'll see that I've got these queries and will provide the implementation for me at runtime. I don't have to write that code. Taking it a step further, I can use Spring Data REST at the top there, at REST resource, and this gets automatically exposed as a RESTful endpoint for me. When people think about NoSQL, they often think about specialized data and sometimes big data. And it's hard to talk about big data without talking about Hadoop. The Hadoop ecosystem today is myriad. It's confusing. It's sort of like the situation we had 10 years ago. We had all these different APIs, and 10 years ago where they didn't integrate with each other. And of course, Spring came along and made it so that you can use struts and Hibernate and all these in quartz together in one kind of web application. Well, now today, big data is the new integration frontier, right? If you're trying to do Hadoop applications, it can be very confusing. Spring for Hadoop makes it simple. But once you've got your Hadoop cluster up and running and you've got your code working, the question is, how do I get data in there in the first place? And there's a new field called stream processing or data integration. And I think this tweet best describes it. It's the most innovative nook of big data today. Our offering in this space is something called Spring XD. Spring XD works in terms of streams. So a stream is the logical flow of data from one component to another. You can process it, you can transform it, etc. Spring XD builds on top of Spring Batch and integration. And so, in Spring XD, data comes in from a source. It gets sent through Spring XD, which is a turnkey appliance, by the way. It's a server, so you can actually scale them out just by adding new nodes and scale out processing. Data comes in from a source. You can route it through Spring XD, do processing, analytics, etc. If you want to funnel data, outside of the mainstream of processing to do things like analytics and auditing and all that, you can do that with a tap. And then the resulting data is sent out and stored in a sink. Now here's an example of me using the Pivotal HD virtual machine. The Pivotal HD virtual machine is something you can download for free from gopivotal.com. It's just a Hadoop distribution in a box with a whole bunch of stuff already set up for you. You can use any Hadoop distribution you want, though, of course. Spring isn't specific to Pivotal HD by any stretch of the imagination. So I have a model. This is a model that was developed by Adam Zwicky and James Williams on our team. This model is already pre-trained to recognize fraudulent orders. And now I'm going to send data into Spring XD. These are orders, some of which are fraudulent. Spring XD is going to route the calls through the Hawk query engine, which has the MATLAB machine learning API in the back there, and it's going to validate whether the order is fraudulent or not, and then light up the appropriate section on the map, depending on how many fraudulent errors or orders we get. So again, this is an example of handling the tidal data deluge of big data, right? So we're processing interactively live, and Spring XD is ideally suited for this kind of thing. Okay. That is, I think, the end of the road here. I'm not sure how we're doing for time, but I want to thank everyone here for staying with me through this webinar. I did an accompanying blog article, blog post thingy, on blog.gopivotal.com. Check, it's called "Have You Seen Spring Lately?" I think it went up just yesterday or the day before. And there's my contact information. We on the Spring team are always happy to hear from everyone. If you have questions, don't hesitate to reach out to us, and of course we'll answer any and all questions here in the webinar, if there are any.
Currently not, but if we only have a minute or two, we're only a minute or two over. So if you do have a question, now's a good time. If not, feel free to just post any of your comments or questions to the YouTube recording that we'll be posting. We usually post it within the week,
right.
at the latest. Do want to just draw your attention to I put the link for, yep, and there it is on Josh's screen. There's a link for the kind of accompanying blog entry. Also, some upcoming webinars that you may be interested in. On December 3rd, we're going to be going through the new sort of async events library that John Brisbane has released, Project Reactor. The 1.0 release just happened about a week or two ago. So we'll be doing a webinar on that on December 3rd, and then December 10th, kind of going back to some core Java basics from Josh Block's, sort of rules of Java, I think is number 15.
Effective Java.
Effective Java, excuse me, is, minimizing mutability or immutability, excuse me, and Matt Stein is going to be presenting that on December 10th.
Matt's the man.
Yeah, definitely. Matt's good. So look forward to seeing you on those webinars. And as we gear up for the launch of Spring Framework 4, which you'll see some webinars for and events for in early January of 2014. So thanks, everyone, and have a great day. And like I said, look for the recording on our YouTube channel. You can find that at spring.io/video. I'm just going to pop the URL for that in here as well.
Yep. Thank you very much for coming, guys. And again, feel free to carry the discussion forward online. We're happy to talk to you guys.
All right. Thanks, everyone. Have a great day. Bye.
Thank you. Bye-bye.